Hello everyone, so today we're going to discuss the nature of the roots of a quadratic equation. So the value of the expression b squared minus 4ac is called the discriminant of the quadratic equation. So let us now characterize the roots of the quadratic equation using the discriminant. If b squared minus 4ac is equal to 0, then the roots are real numbers and they are equal. If b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers and not equal. If b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational and not equal. If b squared minus 4ac is less than 0, then it has no real roots. Before we proceed to our examples, let us have examples of rational numbers. So, rational numbers. Examples of that are, let's say, negative 50. We have negative 25. We have also negative 2. We have negative, let's say 5 over 2. We also have negative 1/2. We also have 0. We also have positive 1/3. We have positive 1, positive 2, and so on and so forth. We have positive fractions. And then the irrational numbers are, example of irrational numbers are cube root of, let's say, 11. We also have a square root of 5. Then we also have pi. And then we also have, let's say, square root of 15. So that's the rational numbers and then the irrational numbers. Okay? So, additional information, if we're going to combine that two, okay, so that it's now the real numbers. Okay, so real numbers are the combination of the two numbers. We have the rational numbers and then the irrational numbers. We have negative 50, we have negative 25, negative 2, negative 5 over 2, we have negative 1/2, we have 0, 1/3, 1, 2, then we have cube root of 11, we have square root of 5, we have pi, we have square root of 15. Okay? Let's start with the first example. Let's say we have x squared plus 6x plus 5 equals to 0. So here we're going to identify the values of a, b, and c. So a is 1 because the numerical coefficient of the quadratic term is 1. So we got it from x squared. Then the value of b here is 6 from the linear term, 6x. So we have 6. The value of c is 5. So this is the constant. Then after that, we're going to get now the value of b squared minus 4ac, which is the discriminant. So equals 2. So substitute, we have value of b is 6. So 6 squared minus 4 times value of a is 1. Value of c is 5. Then we have 36 squared is 36. Then negative 4 times 1, we have negative 4 times 5, we have negative 20. Then 36 minus 20, we have 16. Okay? So 16, as you notice, this is greater than 0 and a perfect square. So here, we can say from the condition, the first condition, that if, so number 2 condition, that if b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers but not equal. So let's go back to this example. So let's see. Let us check. Okay. So to check, let us have the first and then the second root using the formula x of 1 is equal to negative b plus square root of b squared minus 4ac over 2a. So we have negative value of b is 6. Then plus square root of, we all know that b squared minus 4ac is 16 from the solved discriminant. So we have 16. Then over 2 times 1. The value of a is 1, right? So we have negative 6 plus square root of 16 is 4. Then over 2. Then we have here negative 6 plus 4. Okay, negative 6 plus 4, we have negative 2, right? Divided by 2, we have negative 1. Okay, next. If x of 2 is equal to negative b minus square root of b squared minus 4ac over 2a. So, this is equal to negative 6 minus square root of 16. So, b squared minus 4ac, this is the discriminant. The value of that is 16 over 2 times 1. Then we have negative 6 minus square root of 16 is 4. Then over 2. Okay. So, negative 6 minus 4, we have negative 10. Then over 2. So, we have negative 5. Okay. So, as you can see, they are rational numbers and not equal. So, let us write now the conclusion that the roots of the quadratic equation x squared plus 6x plus 5 equals to 0 are rational numbers but are not equal. Okay. Number 2, describe the roots of the quadratic equation 2x squared minus 10x plus 8 equals to 0. So, let us identify the values of a, b, and c. So, a here is positive 2 from 2x squared. The value of b is negative 10. Then the value of c is 8. So, using the formula b squared minus 4ac, we have to substitute. The value of b is negative 10. Square it. Then minus 4 times a is 2. Then c is 8. Now, negative 10 squared is 100. The negative 4 times 2, we have negative 8. Times 8, we have negative 64. So, 100 minus 64, we have 36. Now, 36 is greater than 0 and a perfect square. So, we can say that the roots of the quadratic equation 2x squared minus 10x plus 8 equals to 0 are rational numbers but are not equal. Okay. Next, number 3. Let us determine the nature of the roots. The roots of 4x squared minus 12x plus 9 equals to 0. So, values of a B and C are 4, negative 12, and 9. So A is 4. So this is from 4x squared, the quadratic term. Value of B is negative 12. So we have negative 12. Value of C is positive 9. Okay. The next, using the formula B squared minus 4AC. So that is B is negative 12. Square it. Minus 4 times value of A is 4. Times value of C is 9. The negative 12 squared, we have 144. Then, negative 4 times 4, we have negative 16. Times 9, we have negative 144. Now, 144 minus 144, that is 0. Now, going back to our concept that if, let's see, this is squared. If B squared minus 4AC is equal to 0, then the roots are real numbers and are equal. Okay, so let's check. Okay, so to check, if x is equal to, x of 1 is equal to negative b plus the square root of b squared minus 4ac over 2a. So we have b is negative 12. So negative of negative 12. Then plus the discriminant is 0. So we will just write here 0. Then over 2 times the value of a is 4. Okay. Value of a is 4. So we have negative 1 times negative 12. We have positive 12 plus 0 over 2 times 4. We have 8. Next, 12 plus 0 is 12 divided by 8. Let us get the lowest term of this. We have 12 over 8. Common factor is 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So this is the first root. Now for the second root, we have x of 2 is equal to negative b minus the square root of b squared minus 4ac over 2a. Then we have negative of negative 12 minus the square root of 0. The discriminant is 0 over 2 times 4. Okay. Negative 1 times negative 12, we have positive 12. Then minus 0 over 2 times 4, we have 8. Then we have 12 over 8. Now, lowest term is the same, 3 over 2, right? So, notice that the roots or the solutions are the same. So, the discriminant is 0. So, we can say that the roots of the quadratic equation 4x squared minus 12x plus 9 equals to 0 are real numbers and are equal. Okay. Number 4. Let's say we have x squared minus 6x plus 9 equals to 0. So, getting the values of a, b, and c, we have a is, so a is 1, b is negative 6, and then c is positive 9. So, using the formula, we have b squared minus 4ac. We have b is negative 6, square it, minus 4 times 1, the value of a, times 9, the value of c. Then we have negative 6 squared, we have 36. Negative 6 times negative 6, 36. Then negative 4 times 1, we have negative 4 times 9, we have negative 36. Then 36 minus 36, we have 0. Then, since that the discriminant is 0, so the roots of the quadratic equation x squared minus 6x plus 9 equals to 0 are real numbers and are equal. Okay, number 5. Let us determine the nature of the roots of the quadratic equation 4x squared minus 3x minus 5 equals to 0. Again, first step is we're going to solve for the values of a, b, and c. So we have a is 4 from the quadratic term 4x squared. B is negative 3 from the linear term negative 3x. Numerical coefficient is negative 3. Then c is negative 5. Okay? From the constant, we have negative 5. Then using the formula b squared minus 4ac, so we have negative 3 because the value of b is negative 3, square it, minus 4 times a is 4, then c is negative 5. Then we have negative 3 squared, we have 9. Then negative 4 times 4, we have negative 16 times negative 5, we have positive 80. Then 9 plus 80, we have 89. So notice that the discriminant is greater than 0, but not a perfect square. So going back to this condition that if, number 3, if b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. So let us check, okay? So to check, let us get first the first root. We have negative b plus square root of b squared minus 4ac over 2a. Then we have negative of negative 3 plus square root of the value of the discriminant is 89. So we will just write here 89. Then over 2 times value of a is 4. Okay? Value of a is 4. Then we have negative 1 times negative 3, we have positive 3 plus square root of 89. Over 2 times 4, we have 8. So this is the first root. We cannot simplify this radical because this is not a perfect square, or 89 doesn't have any factors wherein one of its factors is a perfect square. Okay? Next, for the second solution, we have negative b minus square root of b squared minus 4ac over 2a. Again, we have negative of negative 3 minus square root of the discriminant is 89 over 2 times 4. The value of a is 4. The negative 1 times negative 3, we have positive 3 minus square root of 89 over 2 times 4, we have 8. So this is the second root or the second solution. So notice that they are radicals, right? Therefore, we can say that the roots of the quadratic equation for x squared minus 3x minus 5 equals to 0 are irrational numbers. And are not equal. Okay. Number 6, let's say we have x squared minus 2x minus 7 equals to 0. So, let us determine the nature of roots of this quadratic equation. So, find the value of a, which is 1. Value of b, we have negative 2. Then, value of c is we have negative 7. Using the formula, we have b squared minus 4ac. So, we have b is negative 2, square it, minus 4 times a is 1. And then c is negative 7. Then we have negative 2 squared, we have 4, because negative 2 times negative 2, 4. Then negative 4 times 1, we have negative 4. Times negative 7, we have 28. Then if we're going to add it to 4, so 4 plus 28, we have 32. So 32 is greater than 0 and not a perfect square. So here, we can say that the roots of the quadratic equation x squared minus 2x minus 7 equals to 0 are irrational numbers and are not equal. Number 7, let us determine the nature of the roots of the quadratic equation x squared plus 2x plus 6 equals to 0. Now, again, let us identify the values of a, b, and c. For a, we have 1. For b, we have 2. Then for c, we have 6. Now, using the formula, we have b squared minus 4ac. So, that is, b is 2, square it, then minus 4 times, value of a is 1, value of c is 6, then we have 2 squared, we have 4. Negative 4 times 1, we have negative 4 times 6, we have negative 24. Then, 4 minus 24, we have negative 20. So, notice that the discriminant is a negative number, or a number which is less than 0. So, if you're going to go back to the condition that if b squared minus 4ac is less than 0, then it has no real roots. So, let's see. Let's check. Okay? So, to check, for the first root, let us make it 1 instead of separate solution. So, using the quadratic formula, we have negative b plus or minus square root of b squared minus 4ac over 2a. Then we have negative b. So, we have the value of b is 2. Okay. So, we have 2. Then, plus or minus square root of our discriminant is negative 20, right? So, let us write it here inside the radical. So, negative 20 over 2 times value of a is 1. Okay. Then, we have negative 2 plus or minus square root of, notice that the radicand is negative 20. So, if we're going to factor it, we have 20 times negative 1 over 2 times 1, we have 2. But then, 20, if we're going to factor 20, one of its factor is a perfect square. So, let's see. We have negative 2 plus or minus square root of 20. Factors of 20 are 4 and then 5 and then negative 1. Factors of negative 20. Then, over 2. Then we have here negative 2 plus or minus. Square root of 4 is 2. Then you will just copy 5 because that is not a perfect square. And the negative square root of negative 1 is I. So you can put here after the radical I, or you can remove it. You can put it before the radical. So over 2. Then negative 2, let us simplify since that the common factor is 2 here, numerator. So we can now cancel 2. Then we have negative 1 plus or minus I square root of 5. So this is now the value of x. First root is negative 1 plus I square root of 5. Then second root is negative 1 minus I square root of 5. That's it. Okay. Then, going back to this equation, to number 7. So here, since that the discriminant is negative 20, which is less than 0, so we can say that the roots of the quadratic equation x squared plus 2x plus 6 equals to 0 are not real numbers. Or simply you can say that it has no real solutions. Number 8, let's say we have 3x squared minus 5x equals to negative 4. Now, first step is we're going to write this into standard form. 3x squared minus 5x plus 4 equals to 0. So here, you're going to make use of the addition property of equality. You just add 4 on both sides of the equation. Then, solve or find for the values of a, b, and c. So, a here is 3. Then, b is negative 5. Then, c is positive 4. Then, using the formula, b squared minus 4ac. So, we have b is negative 5. Then, square it minus 4 times 3 times 4. Then, negative 5 squared, we have 25. Because negative 5 times negative 5, positive 25. Then, negative 4 times 3, we have negative 12. Times 4, we have negative 48. Then, 25 minus 48, that is negative 23. So, negative 23 is less than 0. So, here we can say that the roots of the quadratic equation three x squared minus 5x equals to negative 4 are not real numbers. Okay, let us have a recap of our examples. For number 1, we have x squared plus 6x plus 5 equals to 0. So, its discriminant is 16. So, the nature of the roots is that they are real, rational, but unequal. Okay, number 2, we have 2x squared minus 10x plus 8 equals to 0. Its discriminant is 36. So, notice that they are perfect squares, right? Greater than 0 and a perfect square. So, the nature of their roots is that they are real, rational, and unequal. The next, number 3, we have 4x squared minus 12x plus 9 equals to 0. So, its discriminant is 0, Therefore, the nature of the roots are real, rational, and equal. Then number 4, we have x squared minus 6x plus 9 equals to 0. Now, the discriminant is 0. Nature of the roots, they are real. The roots are real, rational, and equal. Okay, next. Number 5. We have 4x squared minus 3x minus 5 equals 0. So, the discriminant, we solve for the discriminant and it is 89, right? So, the nature of the roots are that they are real, irrational, and unequal. The number 6, we have x squared minus 2x minus 7 equals to 0. We have positive 32. So, as you can see, 89 and then 32, they are greater than 0 but not a perfect square. So, their roots are real, irrational, and unequal. Next, number 7, we have x squared plus 2x plus 6 equals to 0. So, the discriminant is negative 20. Then, we can say that the nature of the roots of this example is that imaginary, or it has no real roots. Then, number 8, we have 3x squared minus 5x equals to negative 4. Its discriminant is negative 23. Again, since that it is negative or less than 0, then it has no real solutions or roots. Okay? So, you have to remember that. Hello everyone, so today we're going to discuss how the sum and then the product of the roots of the quadratic equation ax squared plus bx plus c can be determined using the coefficients a, b, and c. So, remember, if to find the roots of a quadratic equation, we use quadratic formula, right? We have x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Then, if the roots of ax squared plus bx plus c is equal to 0 are x of 1, negative b plus square root of b squared minus 4ac over 2a. And the second root, negative b minus square root of b squared minus 4ac over 2a. Then, the sum of the roots is defined by x of 1 plus x of 2. So, we all know that x of 1 is negative b plus square root of b squared minus 4ac over 2a. So, let us now substitute that. We have negative b plus square root of b squared minus 4ac over 2a. Then plus x of 2 is this one, right? We have negative b minus square root of b squared minus 4ac over 2a. Then, as you can see, they are similar fractions, right? So, they have the same denominator. Then, what are you going to do is you will just copy the common denominator or the same denominator. Then after that, you combine the numerators. So we have negative b plus square root of b squared minus 4ac. Then minus b minus square root of b squared minus 4ac. Okay. Then, combine similar terms. We have negative b minus b. We have negative 2b. Then, plus or positive square root of b squared minus 4ac. And then, minus square root of b squared minus 4ac. You can now cancel these two. Then, over 2a. Then, after that, we're going to cancel 2 here. 2 divided by 2, that is 1. Since this is negative, so negative 1, right? Then, the sum of the two roots is equal to negative b over a. So here, x of 1 plus x of 2 is equal to negative b over a. Okay? To find the product of the roots, so we have x of 1 times x of 2. So we have negative b plus square root of b squared minus 4ac over 2a times negative b minus square root of b squared minus 4ac over 2a. So notice that they have the same numerators, only that one is the sum of two terms and then the other one is the difference of two terms. Now here we're going to make use of the concept sum and difference of two terms. We have x plus y and x minus y. If we're going to find the product of that, you're going to square the first term minus square of the second term. So let us make use of that. We have negative b squared. So that is the first term minus the second term, square root of b squared minus 4ac squared. Okay. Over 2a squared. Okay. So you're going to multiply again. You're going to multiply the denominator. So next, negative 1 squared, that is 1. Then b squared minus. So square root of b squared minus 4ac squared, that is b squared minus 4ac over 2 squared, we have 4. Then a squared. Then, let us now combine similar terms. We have b squared minus b squared. You can cancel this. We have 4ac over 4a squared. Now, we have, we can cancel 4 because 4 divided by 4, that is 1. And then, we can also cancel a variable because a, common factor is a. A divided by a is 1. So, then a squared divided by a, that is a only. Then we have here c over a. Therefore, the product of the two roots is equal to c over a, right? And then the sum of the two roots is negative b over a. Let us find the sum and product of the roots of each quadratic equation. Okay, so for number 1, let's say we have x squared plus 2x minus 3 is equal to 0. So, again, we're going to find for the values of a, b, and c. So, a is 1, B is 2, and then C is negative 3. The next, to find the sum of the roots, we're going to make use of the formula x of 1 plus x of 2 is equal to negative b over a. So, negative of value of b is 2 over 1. So, we have negative 2. So, this is the sum of the roots. Okay? Next, for the product of the roots, okay? Product of the roots, we have x of 1 times x of 2. We're going to make use of this formula, c over a. So, c is negative 3 divided by 1. So, we have negative 3. So, the product of the roots is negative 3. Number 2. Let's say we have x squared equals to 10x minus 25. First step is we're going to rearrange the terms into standard form. So, we have x squared minus 10x plus 25 equals to 0. So, value of a is 1, value of b is negative 10, value of c is 25. Okay? So, for the sum of the roots, we have x of 1 plus x of 2. So, we have negative b over a. So, negative of negative 10 over 1. So, we have negative 1 times negative 10. That is positive 10 divided by 1. So, we have 10. Okay? That's 10. Next, for the product of the roots. Product of the roots. We have x of 1 times x of 2. That is c over a. So, we have c is 25. Then, a is 1. Okay? So, we have 25. So, the product of the roots is 25. Next, number 3. So, number 3, let's say we have 2x squared plus 6x equals to 1. So, let us write into standard form. We have 2x squared plus 6x minus 1 equals to 0. Value of a is 2. Value of b is 6. Value of c is negative 1. Then, for the sum of the roots, x of 1 plus x of 2, that is negative b over a. So, we have negative of value of b is 6 over a is 2. So, we have here negative 3. So, this is the sum of the roots. For the product of the roots, okay, so x of 1 times x of 2, so that is c over a, right? So, c is negative 1 divided by a is 1, 2 rather. So, a is 2. So, we have here negative 1/2. So, the product of the roots is negative 1/2. Next, for number 4. Let's say we have 3x squared plus 12x equals to 21. Again, rewrite into standard form. We have 3x squared plus 12x minus 21 equals to 0. So, here, I just use the subtraction property of equality. Subtract 21 on both sides of the equation. So, a is 3, b is 12, then c is negative 21. Then, for the sum of the roots, okay, we have x of 1 plus x of 2. So, that is negative b over a. So, we have negative 12 over a is 3. So, we have negative 4. So, this is the sum of the roots. For the product of the roots, okay, product of the roots, we have x of 1 times x of 2. we have C over A. Okay? So, C is negative 21 over A is 3. So, negative 21 over 3. So, that is negative 7. So, that's it. That's the product of the roots. Okay, next, number 5. Let's say we have x times x minus 2 equals to 0. So, what are you going to do is, you're going to multiply monomial by a binomial. So, we have x times x, we have x squared, then x times negative 2, we have negative 2x equals to 0. Then, the value of a here is 1, value of b is negative 2, then c is unknown, that is 0. So, there is no constant, so that is 0. So, to find the sum of the roots, we have x of 1 plus x of 2 equals to negative b over a. So, that is negative of negative 2 over 1. Negative times negative 2, we have positive 2. Okay? Positive 2 over 1. So, that is 2. Okay? Next, for the product of the roots, we have x of 1 times x of 2, we have c over a. So, c is 0, then over 1. So, 0 divided by 1, that is 0. Next, for number 6, we have 1 minus 5x squared equals to negative 3x. Now, what are you going to do is rearrange into standard form. We have negative 5x squared plus 3x, then plus 1 equals to 0. Value of a is negative 5, value of b is 3, then value of c is 1. To find the sum of the roots, again, using the formula, x of 1 plus x of 2. So, we have negative b over a. That is negative. Value of b is 3. Over a is negative 5. So, negative 3 divided by negative 5. That is positive 3 over 5. So, this is the sum of the roots. For the product of the roots, we have x of 1 times x of 2. C over a, that is c over a. Then c is 1, a is negative 5. So, the product is negative 1/5. Okay? So, that's it for number 6. That's so easy. Next, for number 8. Number 8, okay, number 7. For number 7, let's say we have x squared equals to 9. So, you just transpose or you just make use of the subtraction property. You just subtract 9 on both sides of the equation. So, we have x squared minus 9 equals to 0. Then, value of a is 1. Value of b is 0 because the linear term is missing. Then, the constant is negative 9. So, to find the sum of the roots, we have x of 1 plus x of 2, that is negative b over a. So, we have negative, but then 0, there is no, okay, negative times 0, that is 0 over 1. So, we have 0 divided by 1, that is 0. Okay? Next, for the product of the roots, okay? So, we have x of 1 times x of 2 equals to c over a. So, c is negative 9, then a is 1. So, for the product of the roots, that is 9. Okay? We have 9. Negative 9. Okay? That is the product of the roots. Next, for number 8. Number 8, let's say we have x squared minus 9 equals to 3. So, you're going to transpose 3 on the left side, or you're going to subtract rather, 3 on both sides of the equation. So, we have x squared minus 9 minus 3 equals to 0. So, we have x squared minus 12 equals to 0, because negative 9 minus 3 is negative 12. Then, a is 1, b is unknown, that is 0. Then, c is negative 12. Again, to find the sum of the roots, we have x of 1 plus x of 2 equals to negative b over a. So, negative, again, that is 0. Then, over 1, so we have 0. Okay? Then, for the product of the roots, we have x of 1 times x of 2 equals to c over a. So, we have c is negative 12 over 1. Negative 12 divided by 1, we have negative 12. This is the product of the roots. Okay, another example. Let us write the quadratic equation whose roots are the following. Let's say number 1, we have 5 and 2. So, as you can see, this is root 1, this is the first root, this is the second root, right? Now, what are you going to do is you just make use of this formula. X squared minus r's of 1 plus r's of 2x, then plus r's of 1 times r's of 2, then equals to 0. So, we have x squared minus, you just substitute. We have r's of 1 is 5 plus r's of 2 is 2, then x, plus r's of 1 is 5, r's of 2 is 2, then equals to 0. So, we have x squared minus 5 plus 2, we have 7x. Then, 5 times 2, we have 10. So, this is now the equation. X squared minus 7x plus 10 equals to 0. Another example, number 2. Find the quadratic equation whose roots are 3 and negative 5. So, this is the first root, this is the second root. Using the formula, we have x squared minus r's of 1 plus r's of 2x plus r's of 1 times r's of 2 equals to 0. So, we have x squared minus, the first root is 3 plus the second root is negative 5. Then, let us make this one as bracket. Okay? Then, x, then plus 3 times negative 5 equals to 0. Then, we have x squared minus 3 plus negative 5, that is negative 2. Enclose that in a parenthesis. Then, x. Then, this one, 3 times negative 5, that is negative 15. Then, equals to 0. So, we have x squared, negative times negative 2, we have positive 2x. Then, minus 15 equals to 0. Okay, next, number 3. Let's say we have 3 halves and positive 4. So, here, this is the first root, this is the second root. Using the formula, we have x squared minus r's of 1 plus r's of 2x, then plus r's of 1 times r's of 2, then equals to 0. So, we have x squared minus the sum of the two roots. We have 3 over 2 plus 4x, then plus 3 over 2 times 4, then equals to 0. So, we have x squared minus, so 3 over 2 plus 4, that is, we get the LCD 2. 2 divided by 2, 1 times 3, we have 3. Plus, denominator of this is 1. 2 divided by 1, 2 times 4, we have 8. Then, x. Plus, denominator of this is 1. So, multiply the numerators and multiply the denominators. So, we have 3 times 2, we have 12. Then, 2 times 1, we have 2. Then, equals to 0. So, we have x squared minus. Then, 3 plus 8, we have 11 over 2x. Then, plus 6 equals to 0. Now, you can make use of the fractions, but then sometimes we can multiply it by 2, both sides by 2. Okay, so we have, if we're going to multiply this by 2, so we have 2x squared minus 11x plus 12 equals to 0. Where do we get this? So, 2 times x squared, we have 2x squared. 2 times negative 11 over 2, that is negative 11 only because you cancel 2. Then 2 times 6, we have 12. Then equals to 0. Number 4. Let's say we have 5 plus square root of 3. And then 5 minus square root of 3. So this is the first root. This is the second root. Now, using the formula, we have x squared minus r sub 1 plus r sub 2 x plus r sub 1 times r sub 2 equals to 0. So, we have x squared minus, we have 5 plus square root of 3 plus 5 minus square root of 3x, then plus 5 plus square root of 3 times 5 minus square root of 3 equals to 0. Then we have x squared minus, we can now cancel square root of 3 and then negative square root of 3. Positive square root of 3 and then negative square root of 3. Then 5 plus 5, we have 10. Okay? So we have positive 10. Then x. Then plus, we have sum and difference of two terms. We all know the concept of that if we have x plus y and then x minus y, to get the product of that, you're going to square the first term minus square of the last term. So our first term here is 5, second term is square root of 3. So we have 5 squared, then minus square root of 3 squared, right? Then equals to 0. So we have x squared minus 10x, then plus 5 squared is 25, then minus square root of 3 squared, we have 3, then equals to 0. Then we have here now x squared minus 10x plus 25 minus 3, we have 22, right? Then equals to 0. So this is now the equation, quadratic equation whose roots are 5 plus square root of 3 and 5 minus square root of 3. Number 5, let's say we have negative square root of 2 and square root of 2. So this is the first root, this is the second root. Now using the formula, x squared minus r sub 1 plus r sub 2 x plus r sub 1 times r sub 2 equals to 0. So we have x squared minus r sub 1 is square root of 2, negative square root of 2 plus square root of 2 x plus r sub 1 is negative square root of 2 times this one square root of 2, then equals to 0. Then we have x squared minus, now you can cancel negative square root of 2 and then positive square root of 2, so we have 0 x. Then negative 1 times 1, we have negative 1 Then times the square root of 2 times square root of 2, that is 2. Then equals to 0. So therefore, the quadratic equation is x squared minus 2 equals to 0. So x squared minus 2 equals to 0 is the quadratic equation if the roots are negative square root of 2 and the square root of 2. So I hope you learned a lot today. Thank you for watching this video. For more updates and videos, just like, subscribe, and click the notification button. Thank you.